I'm really glad to be back to JavaDay Lviv, but now in a new role on the stage. Thank you. And today I'm going to represent Oracle and the GraalVM team. And I will deliver the presentation in English, not for the sake of the foreign people in the room, non-native speakers, but also for this presentation to be later viewed by a high number of people. I hope so. Let's start. See? So the presentation will be about multi-cloud applications up and running and with GraalVM. And who has heard about GraalVM before? How many people? Very good. Good. And this is another Java virtual machine from Oracle. And it was created, it is maintained, and it is released by the Oracle employees, but we do have two versions, a product and an open source version, and believe me, we have many contributions from outside, and we appreciate those contributions and really encourage. A few words about me. I am Olga Gupalo. I work for GraalVM team, and I belong to product management and developer relations team, but my official title is technical writer, and the responsibilities are the website. I hope you saw GraalVM website before. That's all my duty, and we have, of course, we have a whole team that helps me review, and so everything which goes public goes through the product management team. So that's also the documentation, also accessibility, also training materials, and you can find me at social media by these links. And I joined Oracle a long time ago, that was really a long time ago, uninterrupted. And we do have one more representative of Oracle today. What is on the agenda today, I will introduce you shortly. I will just remind you of GraalVM again, and what is native image, what are native image build tools. And then we will move to ways how to optimize a Java application for file size. And it's not that GraalVM can only help you optimize Java for file size, but there are other aspects and other advantages, because I just want to focus on that particular criteria. And then we will move to demos. I have two demos for today. So let's go on. And if you have a question, just raise the hand, or we can leave some time for Q&A at the end. So what is GraalVM? As I mentioned, that's another Java development kit from Oracle. And two distributions, Oracle GraalVM and GraalVM Community Edition. What are the key differentiators? Why does Oracle release two Java development kits, and actually in parallel? We have the same release schedule, we have the same release module, and who doesn't know, we release every 6 months, and we have the LTS releases the same dates as Oracle JDK, and that means you can use GraalVM for 2 years for free, I mean the product, the paid version, and then you can switch to another LTS release and you still have Oracle GraalVM. Or Community Edition. And Community Edition is based on OpenJDK. And we also have the same CPU releases, so patch releases every 3 months. In total, that's 6 releases a year. And what are the key differentiators? GraalVM is not just native image, because there is this misconception that GraalVM is a native image and native image is GraalVM, which is not true. We have also an optimizing and dynamic compiler, and it optimizes Java applications through unique approaches to code optimization, and the most famous one and featured one, partial escape analysis. So this analysis can reduce the allocations of the object and thus speed up the Java applications. And to get the advantage of the compiler, just switch your Java home to GraalVM. That's all you have to do. And the second in the list is native image, and that's exactly the stack that I'm going to try today and show you during the presentation, and more details in the next slides. The other differentiator is Polyglot API. That's something very, well, that's unique, and unique to GraalVM. It means you can embed languages in the Java, like other languages code in Java code, and we release Maven artifacts for other languages Python for JavaScript, so you just add that language as a dependency in your Maven or Gradle build file, and then you can create a context, JavaScript context in the Java application. That's another topic for another presentation, and we have more information at the website. The documentation is extensive, and there are also examples of those polyglot applications. But let's move on to where you can get GraalVM. Same where you can get Oracle JDK on the Java downloads page, but I will recommend you to go to the website and the downloads page on the website, because there we offer more options. And SDKman works the best, and also SDKman gives you the possibility to install early access build of GraalVM, and GraalVM for JDK 23 is going to be released only in September this year, but you already have the early access builds with the latest features, and I will be using that version today, and I want to show you some of the features that will be just released. And whoever prefers GitHub Actions, container images, that's all. Well, Nicholas was using the container image version of native image, and you saw it today in the Docker file. So what is native image? Native image is a tool chain. It's an ahead-of-time compilation tool chain. It is provided with GraalVM. It's in the package. You don't have to install it separately anymore. And it also leverages the Graal compiler, which I mentioned before. Then it also uses Substrate VM. That's a runtime layer, which was that's another implementation of the GVM, and it was tailored specifically for native image. So when you package your application into a native image, and if you look into the packages inside, in the classes which were included, you will also find the SVM classes, because that's the runtime. And we recommend native image solution for workloads that you would like to deploy in a container or CLI application that works the best, and microservices. What actually happens? You provide Java bytecode, and native image tool will transform it into a platform-specific executable, and it will be specific for a platform and for the architecture. And as an input, you can provide or jar files or class files or Java modules as well supported. And also we will have a demo on that later. What is actually happening under the hood if you want to know more about ahead-of-time compilation? So as I mentioned, you provide the input, and then the native image tool runs its static analysis. And this static analysis you can see in the middle of this graph, right? And what happens first? Native image tool runs points to analysis. It analyzes what data, what classes, fields, method are reachable by your application in runtime, and if the classes will be safe to be initialized, and then native image tool initializes those classes. And it initializes those classes on the JVM. And then values are written to static fields and saved in the heap. And then native image, native image does heap snapshotting of that static state. And that snapshot is written to image heap. So by image heap, I mean the application heap, the binary heap. And then you have, right, the native binary for a specific platform. So at the end, you have a binary, which can be or a native executable file, or it can be a shared library. A shared library, what I mean, for example, you would like to use your Java in a native program. So then you will compile it in a shared library and then use it in a C and C++, for example, and as an import. Let's move on. And that leads us to this slide about advantages. What advantages does it give you? Fast startup. When you compile application into an executable file, it's static. It's not dynamic. You cannot dynamically include you cannot call other classes dynamically at runtime. So it's static, and it does not require a JVM to run. That's the most important. So it provides peak performance with no warm-up. So you copy this file, executable, say I compiled it on my macOS machine, then I copy it to another macOS machine, this M1 processor, and it will run. You don't need a GTK, you don't need a GVM. And you don't need to warm up. So that's fast performance, fast startup, that's promised. And then lower resource usage. Because the application is shrinked, native image tool, when it does this optimization, points to analysis, it also stripes out all unnecessary code that is not reachable by your application. So it only packages what it deems reachable and safe. That means that footprint will be lower and their performance will be higher and the CPU and memory usage will be also lower. And if this resource usage is lower, reduced, then it also means you don't need much more resources on the cloud machine, for example, or on your host, whatever host you have. Predictable performance. The application is stable, it's static. You fix the resources at build time, so native image should know about all the resources you are going to use at runtime at build time. So build time, it's where you compile your application into a native image binary, and runtime when you run it. And we created this term build time just to differentiate between compile time, not to confuse between JIT and ahead of time compilation or AUT compilation. So performance will be predictable because your application doesn't load anything extra. You know what it was before, and it will behave exactly the same. Improved performance, improved security and compact packaging. So what I mean by that, security is improved as well because code area is reduced. Less libraries, less code, less attacks. Then compact packaging, that's exactly what I'm going to show you today. The application is really shrinked, and you can shrink it even more. By default, it's shrink, but there are other optimization means that you can use to shrink it even more, and then package it into a container, for example. And finally, the other advantage, which is really significant, this is the community adoption, the adoption by the Java users, and the frameworks that I listed, Micronaut, Spring, Quarkus, Helidon, they all have the built-in support for native image, and we cooperate with those teams, with the framework developers, how to even improve the user experience more and more. And also it's adopted by the major cloud vendors. So why do I use the word multi-cloud applications? Because you can deploy the same native binary or on Oracle host machine, or in on Azure, or in, for example, using Google Cloud Run, or then you can use any Kubernetes engine from the cloud providers, for example, AWS Elastic Kubernetes service, so whatever your plan is, but that's all possible. And we do have guides for example, deploying Micronaut microservices on those clouds. And next, what I want to mention before we go to the demo part, these are native image build tools. These are Maven and Gradle plugins that we also develop, and we publish them. We publish them to help users really use native image. The plugins help you test, configure, and build native executables as part of your Maven or Gradle build. And you can run JUnit test, for example, on a native executable. More at the website. And this is an example of a configuration snippet that I have in my application, and actually that's the default one. You specified the plugin, Maven plugin, as part of the Maven profile. And now let's move on and talk about, let's review ways how you can optimize a Java application for file size. So most important, you can just reduce the number of libraries that your application use, like whatever you can do, that's on your own. What you can do next, you can compile your Java application into a native binary using GraalVM native image. Next, you can apply the optimization for file size, which is possible with GraalVM native image as well, and we will try that as well and see the advantage. Next, what you can do, you can package a native binary executable into a container. And we will take advantage of different native image linking options for that. Number 5, you can use as small container as possible because a native binary doesn't require a JVM. So you don't need Java libraries provided by your operating system for the application to run. Just use the smallest container possible, it will run. And then finally, what you can do, you can compress it using this UPX open source file compressor, which we also use. It's available out there, and it's very well suited for Linux. So let's move on to the demo part. And before I switch to the development tool, I will tell you a few words about my environment. I'm using a host machine on Oracle Cloud. Of course, I will use Oracle Cloud. And that's Oracle Linux 9 image and the CPU count. So my configuration is very basic. It's one CPU count, 16 gigabytes of memory. And for the Java runtime, of course, I'm using Oracle GraalVM, but early access build that will be only released in September. And because I want to use some of the cool and latest features. So let's move on. And I work in VS Code. I'm not using IntelliJ because for technical writers, for managing the website, VS Code is just perfect. You have the Java support for some demos and for writing guides. And the first demo, it will be a Java application that leverages LangChain for J. And LangChain is a Java implementation of LangChain for J is a Java implementation of LangChain, and I'm using that version because that's the only which is available. And also it leverages OpenAPI chat model 4.0, the fastest and the most affordable now. And well, that's a very plain one. You can see you can see the code on the right of the slide, and the most important bit, right, where you specify what chat model you're going to use. And also, I enhanced that application with native image Maven plugins. And this application is actually based on LangChain for J example, which is available on GitHub. Nothing fancy. The OpenA key, which is required for the application to run, I just exported it as an environment variable, and the application will just read the environment variable. So, 2 steps. We are going to package it as a native executable, default mode, no optimizations, and then we will compile it ahead of time, but with the file optimization on. Oh, too far. So that's the application. I have 2 build scripts, and this is the POM.xml file. And the dependencies, dependencies are minimal, like very few LangChain dependencies and TinyLog for logging. And then we have the regular Maven plugins for packaging the application. And I need a fed jar because native image requires a fed jar with all dependencies. And then we have the profile. A moment, I will increase. Do you see it well? Show me. Better? So we have the profile, and one important bit here, I enabled another extra flag, which is build report. That's a host option, but we will replace it with a public API in the next release, and that's because I haven't done it, but it's coming. And I would need this report to show you. You can actually have the report generated in the command line, but I would like to show it in a more fancy way and with better visualization. So let's package this application as a native executable. All I do, I just run Maven with native profile, and Maven will package it into a native executable. It will take around 2 minutes on the host machine. For some reason, on the remote host machine, it will take longer than on the local machine. And meanwhile, let me show you Let me show you the build report that I'm expecting to see. I have generated it just before the presentation on my local machines, so I can open it in the browser easily. That's actually the build report. And native image tells you what Java version you are using and what is the optimization level. That's a level B, which means quick build mode, to make the build process quicker. And also, like, which garbage collector I'm using. By the way, when you package your application ahead of time into native image, it only will use one garbage collector, not all of them that are available in Java. Also, how many classes it finds reachable, how many classes are registered for reflection, for GNI, for well, in total loaded, then some image details like how much code area, how much image heap, and then also the security report. It tells you enable SBOM, but it's really not necessary because I'm using Oracle GraalVM, that's an enterprise version, and the SBOM software bill of materials, it's already generated, and you can see exactly what is in your application. And you can use, for example, Sift. You know that tool? Sift? Snick? Well, that's an alternative, but the tool is open source, and you can also check what is in the native executable by extracting the SBOM. And Sift has support for containers, so it can tell you not only what is in your executable, but also what is the how number of files, packages are in the Docker container. Let's go back to the demo. Almost there. During the build time, there are 8 phases. So first, native image analyzes the environment, and that's actually all the same that you just saw in the browser version. Then options that were unlocked that native image will use, and using this plugin, you can pass as many options as you like using the configuration element. And see, I'm just passing new options. Same as I would do on the command line. So we have 6 out of 8. It's almost there. And in this field, you can see how many reachable methods. So 56%, 57% of 100 methods were reachable, where native image marked them as reachable and actually packaged like in the native executable. That means others were just stripped out. They are not in the image. That's what I meant by security, squeezing everything unnecessary. And so image is generated. Let's chat. Executable is generated in the target repository as always, and let's wait for OpenAI to respond, which will take a few seconds. Voila. JavaDay is a conference in Ukraine. Let's ask something else. It will take longer to answer. You know, I was checking what information I can get about native image, GraalVM, and you know, it does not correspond to the reality. And that means that the documentation team does not work well. we should produce more materials and teach it. Right, so what I like the most, affordable. Coffee and chocolate. Food. Okay. So the next step will be to package the same executable but with the file size optimization on. I have just done it before the presentation to save this extra 2 minutes time, and I will show you the build script. So this is the build script. And what I did, I substituted this option. I actually used the new option which is coming out -OS. optimization for file size. I'm passing the jar file, the fat jar, and then I'm allowing some classes on the image class, and then I also generate the build report for this build, and I specify a different name for the image, so we have both, and we can compare. And that's my searchbot optimized image. I do have it, and let's just compare the file sizes. It will work the same way. You can interact with it as well. Yep. I'm not used to typing on stage. It will tell us that I cannot provide you real-time data. That's obvious. But you see it works. So let's check the file size. How much we gained by just compressing. By just compressing with native image means by using this new optimization. Oh. Voila. So let's see. We have the fat jar, which is 193 megabytes. And then we have the first version, unoptimized version, which is 35 megabytes. And then we have the optimized one, which is just 30. It's a nice reduction, though. And that's a CLI application and really, really minimum. Let's move on. So that's first half of my demo. You can see you can already optimize the file size. What we can do next?
Sorry, can I
Yes.
ask a question? So you showed a software bill of material. Is it available only for the production GraalVM?
Yes. Yes. Just to recap what we just did, we packaged this Maven, then we ran Maven and plugin to Maven profile to create a native executable, and then we examined as well the build output. The second step was ready. 15 minutes left. The second step was to optimize for file size. And these are the results that we obtained with just one optimization on. And there are different optimizations available. You can optimize for memory by switching the garbage collection policy. You can optimize for performance. What I mean by optimizing for performance, if you initialize more classes at build time, less will be left to be initialized at runtime. And it means at runtime, the native image, actually the executable won't do these checks to check if the object is already in the heap. That saves the performance. But this build time initialization has pros and cons. And yes, it can save you performance, but you can also accidentally save something, for example, sensitive. And what else you can do? You can optimize for file size, performance, for latency and throughput. You can optimize for security. And this is just one aspect we are exploring today, how to optimize for file size. And the fourth advice was containerize. Take advantage of different native image linking options. And my colleague, Sean Smith, said, he is actually our guru, container guru, that place the Java application in a container, the environment that you can control. And what are the native image linking options? I'm speeding up, you see. I'm trying to cover everything I planned. Dynamic linking, fully dynamic linking. That's the default mode. So when you build your application ahead of time, it is a fully dynamically linked application. And it requires that the operating system you run it on provides you native libraries it is linking against too. So the glibc, zlib, and that's default mode. But then what you can do, you can use the second option. You can build a mostly static native executable, which will be linked against everything except glibc. So the operating system has to provide the glibc library, the glibc toolchain. And then what you can do, you can build a fully static native executable, which will be very, very self-contained. And then you can deploy it on even the most flat, minimal container that could be Slim container or Scratch container. and you can run it, and it will work, and we will see it. You will see it. So demo part 2 is JWeb server. I took the JWeb server from GraalVM JDK, and I will compile it ahead of time. And since I manage the website, I will show you how to run it, how to run JWeb server and GraalVM website in a Docker container and on Oracle Cloud. And the environment here, so that's important. To take advantage of linking options, you should be on Linux, whether it's Intel or Arch 64. And then, yeah, we will need Docker or Podman, and then also GraalVM. Yes, and we will need some muscle toolchain and zlib toolchain to build a static image, fully statically linked image. So let's move on, and we will. Here there are 5 steps. First step, I would like to show you. The custom runtime image generated with JLink. No native image involved, just JLink, and then we will move on and we'll build a fully dynamic image, mostly static image, and fully statically linked image. And then we will compress it with UPX. I'm switching to my VS Code, and that's the second demo. And you see I have a bunch of build scripts and a bunch of Docker files. Let's start from the JLink version. So build JLink runner. So that's the script. What I am doing, not that one, this one. This is the JLink command. You see I'm passing the module, the JDK HTTP server module, and also a bunch of other options just to strip everything necessary so it's as minimal as possible. And then I run the Docker build and I apply the Docker file. And see what is in the Docker file very quickly. I am using distroless Java-based container, which provides me enough of Java libraries. It's not a full JDK, just enough of Java libraries to run this JLinked version of the application. And we can actually run it. I will show you. Docker images. What do I have there? Yeah, we have it. Okay. Let's map the ports. And oops. Yep, it's there. So let's move on to the browser. And here you are. That's the documentation and for JDK 20 version. So what actually happens, I am copying the JLink runtime, image runtime, into the container. And I also copied a bunch of static pages of the website. And what the container does, what the Docker image does, I specify also the entry point, the index file, which is in the package. So that was rather simple. And just to give you, so that's the Docker file I was using, right? I'm copying the image, the runtime, and then I'm copying the site pages. I expose the port, and also then I specify where to start, what is the entry point. And let's stop this container. Okay, done. Let's move on, and next we will build dynamic versions of the default native image version. And whilst building, I will show you again what is happening. This is the native image command. So I specified the optimization. That should be a quick build mode, not even the file size optimization, just quick build. And also I tell what should be the name of the final executable image. And you see I'm specifying the module which I build this application from. So it will take a minute and a half. And what is in the Docker file? You can see I'm using the same base image, the same Java-based image with just enough libraries to run the application. It's enough. And then I also do the same, I copy the files and so on. The scripts and both demos are available on GitHub. All the scripts And also, I added the README file with instructions how to actually repeat what I just did, step by step. So at the end of the presentation, you will see the slide with the link to my GitHub account. So we're almost there. Let's give it a moment. Just to recap, we are building a native image default mode, no extra stuff for file size optimization, default mode. Next, we will build a mostly statically linked native executable. And for that, we will need a different Docker container image, a different image in the container. And that will save size because we will use even smaller Docker image. Image is created. Let's move on. The website, believe me, will run as it ran before. Let's just move on. I have just 10 minutes left, sorry. The next build is mostly static. While it's building, let's look at the build script. So here you see I specify a new option, static no libc. This option tells me please link against everything except libc. And then all the same, and I specify a different name for the image at the end so we can differentiate. And we run the Docker build. And the Docker build is as follows. I'm telling please use pull a different different image, and this time it's a distroless image, base image, no Java libraries at all. And it's smaller in size. It will save us a few megabytes for this application. What I should also mention, this folder site, it weighs 44 megabytes. These are static pages of the website. So it adds plus 44 megabytes to the final image size. Take it into account. So we are running a full native image build this time, and if you look at the if we look at the beginning, so this time you see so the optimization level, the Graal compiler, the target machine, and so on and so on. Also different data for how much types, fields, and methods are deemed reachable that native image will actually package in the final executable. And then we are building the compiling and inlining, parsing, whatever else is required. Done. Image is copied in the Docker container, and Docker image is ready. And let's run the final one. Let's build the final one, which is fully static image. And this time, just a moment. So we need a static. 5 minutes left, but we started later, so it doesn't count. I will take 5 more minutes, okay? So what happens now? I'm building a static runner, a static application, fully statically linked application. See what I'm doing? Yeah, I'm providing some native tool chain for the native image, which is a requirement for this run. And then the build configuration includes 2 more options. Build, please, a static image, and please include libc, include muscle C. So, for this image to be created, we need a muscle C implementation, dependency. And muscle C is a lightweight implementation of libc, and that's what I'm specifying with this flag, which is really required. And then we actually run the Docker build, and this is the Docker build, Docker file. So I am pulling a Scratch Docker image. This is a Scratch container from Google, which is an official Docker image. You can use it. It's absolutely plain, and it weighs 1.5 megabytes. And it still contains some certificates, something which is really required, but no native libraries, no Java libraries. It's really plain. And we are doing the same. We are copying the executable into the image, into the Docker image. We are copying the files, website pages, and also specifying the port and entry point. Nothing new. What else can do? You can also build a native executable inside the container. So you notice I'm building the executable on my Linux machine, on the host, and then I copy the executable to the Docker image. But you can do both. For example, what Nicholas did in the presentation, he was building a native executable inside the Docker. inside the Docker container. And finally, let's compress. So we're going to use the same native executable, but we will compress it using UPX compressor. I should notice that the compressor actually copies, downloads the executable into the memory, native memory, decompresses it, and then compresses again. So that's a disadvantage because you should take that into account. And we are done. Before we check the file sizes, I will still check if the application still runs, if the JS web server is still up and running. Let's close this. Okay, let's find. Okay, let's do this. Docker images. Let's see if we have the images up. Yes, we have all the images we need. And then well, now you see the sizes, sorry. I disclosed. So, what the file size with JLink image in? That's 166 megabytes. And then we squeezed it to almost 50, like 3 times less. And you see the degradation from 166. Then we have the default native image in the container 93, and then we have mostly static. And mostly static image, this file's container image size is decreased because we used a different container image, and then the different base image, and then we have the static one, which is Scratch. The container is really minimal, and then we have the compressed version. And the compressed version is that the executable was compressed, and then we copied it back into a container image. And the executable, like the final size, 49.7 megabytes, minus 44 megabytes of the files that we copied into, and 44 these website pages, minus 1.5 for the container size, and then we have the executable. That's all. And it will run the same way as the JLink version as well. So let's just give it a try. I am wrapping up. Oops. Well, actually, yep. And we will run. This is our container. Let's run the most compressed image. Yeah, it's still. Let's check if it's still up. Yes, it's still up. Nothing has changed. I hope that was convincing. That try native image, package it in the Docker container. You can even compress it if you like. It's like an extra final step, but native image is already sufficient, especially the mostly static linked version. Depends what your application is and what is it about. So just to recap what we did, these are the same Docker files and the build scripts. For JLink, for dynamic image, then we have mostly statically linked image, then we have the Scratch container and the static image in, and finally we have the compressed version. And these are the results we just saw. So at the top of the file, you see the file sizes for executables. These are the executables I created on the machine, on a remote Linux host. Down you see the sizes of Docker containers. And just to recap, what you can do with the Java application to optimize it for file size, reduce number of libraries, apply native executable, apply native image to optimize it, to shrink it, then apply the optimization for file size with native image, then you can containerize using different linking options with native image. Use the smallest possible container if that's possible, if that's sufficient for the use case, and you can even compress the executable more and package into a Scratch container. And finally, one last thing to know that for your application, like for example, you build an application and it's specific for a platform. But if you use GitHub Actions, because there is a GitHub action for GraalVM, you can build it. You can build for macOS, you can build for Linux, and specify in the action that you would like it to produce the artifacts, and then you have the zip file, just download and share, copy, send. And according to our license, just to remind you, it's a free terms and conditions license for GraalVM, which allows you to share native executables, like share your applications as native executables, but not for fee. So, thank you. The resources I mentioned, the website, check our website. SDK man command to install the latest and greatest early access builds with the features I just showed. Then you have the account, my GitHub account link, and then where you can find me. I used mostly Twitter, also LinkedIn works. Some Q&A, and let me show you the website. Please go check. Send me the feedback if you like, but just do it directly. No need to submit a GitHub issue. Any questions? Yes.
I have a question. What are the drawbacks of using this
Ahead of time compilation?
Yeah, optimization when you reduce the size so much?
We have different optimizations available, and this file size optimization is between build time optimization, so shrinking time to build executable. You saw it took like 2 minutes for us to build the length chain application ahead of time, so you will shrink that time. But there is also optimization for performance. So this file size optimization in between. It takes something from build time, it takes something from performance optimization. And these are not the optimizations that native image provide. These optimizations by the Graal compiler, by the just-in-time compiler. So the compiler is also involved in the ahead-of-time compilation. And let me just show you. Just a moment. Optimization and performance, and let's switch to the last version. So these are the descriptions of all the optimization levels. I'm just talking about optimizations of the compiler, but there are also other optimizations for memory, like using the different garbage collector, or you can specify the maximum heap size that your native image will use. That's also for memory. And the drawbacks, I see only advantages, like reduced code size, better security.
Why not just use the last one option?
By default?
Yeah.
Maybe it will come. This is the first release we introduced in this option. So our developers have worked on that for the last couple of months. And the early access build with this option in was created just last Monday. So I grabbed it, and here you are.
So we don't know drawbacks yet.
Not yet. Give it a try. Send us the feedback. We have open Slack, the channel for community, and thank you. Any other questions? Okay, then we are done. Oh, application, because for this small CLI application, that you won't see any advantage of it. Like you can see the advantage if you run per profiler. You will see then the number of instructions difference, but just on the command line, that's not really visible. But for a long-running application or application that requires throughput and latency, better throughput and latency, that's the recommendation. And it will also squeeze the file size. Any other questions?